Now it's time to look at parallel lines and proofs. We're going to look at some of the theorems that we had yesterday, and we're going to actually prove them. And then we're going to look at the converse of each of our theorems and talk about what we can conclude when we're looking at the converse. So for our first example, we're going to prove the alternate interior angles theorem. So yesterday we said if the lines are parallel, then alternate interior angles are congruent. So what we're doing is we are proving why this works in all cases. So obviously we're going to start with our given, knowing that they're parallel. So that will be our given. There are a couple different ways to do it. Try to, do it in the most straightforward approach. So for statement 2 and 3, you'll notice they look similar. For statement 2, it says the measure of angle 1 plus the measure of angle 3 equals 180 degrees. And for statement 3, it says the measure of angle 5 plus the measure of angle 6 equals 180 degrees. So I used those pairs. I could have used different ones, but in statement 2 it uses angle 3, and in statement 3 it uses angle 6, which I knew I was trying to prove those were congruent, so I went ahead and used a statement that includes both 3 and 6. And this is just the linear pair property. They form a line, so that means they're going to add to equal 180. So the reason for both of those is linear pair property. Okay, so now that I know with statement 2 and 3 that they both equal 180, then that means they must equal each other, and that's because of the transitive property. So for my next statement, I'm just going to say measure of angle 1 plus the measure of angle 3 equals the measure of angle 5 plus the measure of angle 6. And again, that's because in both of those statements, they equaled 180 degrees. So that means they must equal each other. And that's your transitive property. So for my next step, and this is where, if you were doing this proof completely by yourself, you might get stuck. My next statement is that 1 and 5 are congruent. So I'm going to look at my picture and look for 1 and 5. 1 is right here, 5 is right here. I know that those angles are congruent because they're corresponding, because of the corresponding angles postulate. So I am going to use that next. So now what I'm going to do, if you look at the reason it says substitution, but there's a reason that I made statement 5. So what I'm going to do is I'm going to take my statement 4 and I'm going to take my statement 5 and I'm going to kind of put them together. So I'm going to take out this measure of angle 1 and I'm going to replace it with the measure of angle 5 because I know that those are equivalent. So when I replace the measure of angle 1 with the measure of angle 5, and I could have also replaced the measure of angle 5 with the measure of angle 1. It doesn't matter. You want to replace one of them, not both of them. That way, if you replace both of them, then they both switch and now they're not the same thing. So we want them to be the same thing. And you'll see why in just a second. So this is going to become the measure of angle 5 plus the measure of angle 3 equals the measure of angle 5 plus the measure of angle 6. And again, we substituted in step 4, we took the measure of angle 1 out and we replaced it with the measure of angle 5. So that's substitution. So now if you look at it, what you'll see is we have the measure of angle 5 on both sides, and that's a good thing because what we're going to be able to do is we're going to be able to subtract the measure of angle 5 on both sides, and that is going to eliminate the measure of angle 5 altogether, leaving me with the measure of angle 6. I'm sorry, the measure of angle 3 equals the measure of angle 6. So we are going to do subtraction. And then finally, at step 7, you can see it says the measure of angle 3 equals the measure of angle 6. That's almost what we want to prove. We want to prove that they're congruent and their measures, which means their measures are equal. So anytime we go back and forth between congruence and equality, we're using that definition of congruence. So our last statement should be that angle 3 is congruent to angle 6. So now we have proved that alternate interior angles, because 3 and 6 are alternate interior angles, that they will be congruent as long as your lines are parallel. So we're going to do a similar proof this time, but instead of proving the alternate interior angles theorem, we're going to prove the same side, or that's consecutive interior angles theorem. So with that, what we're trying to say is if we know the lines are parallel, then 3 and 5, or you could use 4 and 6, are supplementary. And remember that supplementary means that their sum is 180 degrees. So that's what we really need to get to, is that their sum is 180 degrees. So let's go ahead and start with our given, which is that M and N. That's really bad. Let me redo that. M is parallel to N. Okay, and so for my first statement, I've got the measure of angle 1 plus the measure of angle 3 equals 180 degrees. Look at your picture. Those are a linear pair, so they are going to add to equal 180. So linear pair property. All right, so the next step, like if we want to prove 3 and 5 are supplementary, then I need to have the measure of angle 3 plus the measure of angle 5 equals 180, which I almost have that, but somehow I need to get 1 to be angle 5. So if we look at what we have, we do know that the measure of angle 1 is equal to the measure of angle 5 because of the corresponding angles postulate. As long as those lines are parallel, then any corresponding angles are going to be congruent. I'm going to run out of room. Squeeze it in there. Okay. So now what I'm going to do is I'm going to replace the measure of angle 1 with the measure of angle 5. So the measure of angle 5 plus the measure of angle 3 equals 180 degrees. That's substitution because I replaced the measure of angle 1 with the measure of angle 5. And now 3 and 5 were the two angles that I was looking for. Those are those same side interior angles, or those consecutive interior angles. I have that they equal 180, which means they are supplementary because that is our definition of supplementary. All right, and that is it for this proof. You will prove that alternate exterior angles are congruent in your homework tonight. It will look very similar to that first proof that we did. All right, so everything that we've talked about is if the lines are parallel, then these things are true of these specific types of angles. Okay, but what if we look at the opposite of that? What if we know specifics about the angles? What can we conclude about the lines? And so these are converses of your postulates and your theorem. And the converse just means the opposite. So our corresponding angles postulate says, if the lines are parallel, then corresponding angles are congruent. The converse of that says the opposite. It says, if your corresponding angles are congruent, then you know your lines are parallel. So for an example of this is if we know, and I'm just going to pick one pair of corresponding angles. So if angle 1 is congruent to angle 5, then we know L is parallel to M. And that would be true if it was any pair of corresponding angles. So I could replace angle 1 and angle 5 with 2 and 6, 3 and 7, or 4 and 8. But if you know those corresponding angles are congruent, you can conclude that the lines are parallel. All right, so then we have the converse of the alternate interior angles theorem. So that states if your alternate interior angles are congruent, then your lines are parallel. There are two pairs of alternate interior angles. So there's 4 and 6 or 3 and 5. So I'm just going to use, I don't know, 3 and 5. So if 3 is congruent to angle 5, then we know L is parallel to M. Okay, remember alternate interior, they're in between the lines. And alternate is the angles on the opposite side of the transversal. So of course, then we have the converse of the alternate exterior angles. So if any alternate exterior angles are congruent, then you know the lines are parallel. So you've got angle 1 and angle 7, or angle 2 and angle 8. So I'm just going to use angle 1. It's congruent to angle 7. Then L is parallel to M. And then finally, our last pair of angles that we talked about were those same side or consecutive interior angles. And what that theorem said was if your lines are parallel, then those same side interior angles are supplementary. So the converse would say if your same side or consecutive interior angles are supplementary, then you know your lines are parallel. So for that, you have two pairs of same side interior angles. You have 4 and 5 or 3 and 6. So it would say if the measure of angle 3 plus the measure of angle 6 equals 180, then you would know L is parallel to M. I'm going to rewrite that. It looks pretty sloppy. L. There we go. So these are nice to know because, sometimes you don't know if the lines are parallel, but you can look to these angles and hopefully then make the conclusion that the lines are indeed parallel. If they're not parallel, then none of this stuff is going to be true. So it is important to make sure that you establish whether or not these relationships exist. All right, so for this one, I'm gonna give you some information about some angles, and you're gonna decide if the lines are parallel. If not, you can just put not parallel, and then give me the appropriate converse that allows you to conclude this. So for A, we have 9 is congruent to 22. So here is 9, and here is 22. All right, 9 and 22 are on Q and R. If those are congruent, then we can conclude that Q is parallel to R, and that is because of the converse of the alternate exterior angles. So, oops, to help to spell it correctly, let's try that again. Converse of alternate exterior angle theorem. All right, so now let's look at 8 and 13. So 8 is right here. Let me do a different color. And here is 13. On this one, we are told that they add to equal 180 degrees, which means they're supplementary. 8 touches line P and 13 touches line Q. Because those angles are supplementary, then we are going to be able to conclude that P is parallel to Q, and that is by the converse of, you can either use whichever term you like, same side interior or consecutive interior angles. The converse of same side interior angle theorem. All right, and then our final pair of angles that we're looking at would be 1 and 17. So 1 is here, which touches P. 17 touches R. Because they are congruent and they are corresponding angles, we are going to be able to conclude that P is parallel to R by the converse of the corresponding angles postulate. That's the only one that is a postulate, is the corresponding angles. Everyone else is a theorem. So now we're going to prove some of our converses. So for this example, we are told 4 and 5 are supplementary, and now we're proving the lines parallel. So we're proving the converse of the same side interior angles theorem, or consecutive interior angles theorem, which we proved the regular theorem in our second proof. So we're starting with 4 and 5 are supplementary, and that's given to us. Okay, so what does supplementary mean? Okay, well, supplementary means that if you add them, so measure of angle 4 plus the measure of angle 5 equals 180 degrees. That's what the definition of supplementary is. So now if I look at it, my next statement says 1 plus the measure of angle 1 plus the measure of angle 4 equals 180. So look at the picture. Those are not any of our special angles like corresponding angles. That's your linear pair property. Okay. What I do notice, though, I've created two statements, both equal to 180. So if they both equal 180, they must equal each other. So now I know that the measure of angle 1 plus the measure of angle 4 equals the measure of angle 4 plus the measure of angle 5, and that's that transitive property. If they equal the same thing, they must equal each other. And I could have written it the opposite way, but it doesn't matter. In the end, we can get it to be in the exact same order. So now as I look at this statement, what I see is I have the measure of angle 4 on both sides. So I'm going to be able to get rid of that by subtracting it. So that's my next step, is to do subtraction. And if I subtract the measure of angle 4 from both sides, it's going to give me the measure of angle 1 equals the measure of angle 5. Okay, well, if their measures are equal, then I know they are congruent. So that is going to be my next statement. Angle 1 is congruent to angle 5. That's our definition of congruence. And if I look at 1 and 5, those are corresponding angles. And so if my corresponding angles are congruent, then I know my lines are parallel. That's the converse of the corresponding angles postulate. And I may not have room to write postulate, and I'll do my best. Angles, postulate. Because that one's a postulate, if we can get down to corresponding angles being congruent, then that's going to allow us to prove the theorem we're trying to prove. Remember, postulates are used to prove theorems. All right, and our final proof that we're going to do is we are going to prove the converse of the alternate exterior angle theorem, because we know that 1 and 8 are congruent. So we're trying to prove that lines A and B are parallel. All right, so let's start with our given. Angle 1 is congruent to angle 8. I know if the angles are congruent, their measures are equal, so I'm going to take the congruency and make it an equality statement. So that's our definition of congruence. Remember, it can go both ways. Now I'm going to make the statement that the measure of angle 1 plus the measure of angle 2 is 180 degrees. And if you look at that picture, you can see that that would be accurate because those form a linear pair. So that's our linear pair property. And then for step 4, the measure of angle 4 plus the measure of angle 8 equals 180. Also linear pair property. All right, so I have two statements that both equal 180, so my natural next statement is going to be to set them equal to each other, and that's using the transitive property. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4 plus the measure of angle 8. All right, so now I'm trying to get that the measure of 1 is equal. I'm sorry, I'm not trying to get that. That's what I had. We were told in our given that the measure of angle 1 equals the measure of angle 8. So what I'm going to do, because I have the measure of angle 1 on the left side and the measure of angle 8 on the other side, I'm going to replace one of them. It doesn't matter which one, with the other. Don't replace one. Don't replace both. Either take one out and replace it with the measure of angle 8, or take the measure of angle 8 out and replace it with the measure of angle 1, which if you look at statement 6, you can see that that's what I did, is I took the measure of angle 8 out and I substituted it with the measure of angle 1. So replaced it or substituted it. And now that we have the measure of angle 1 on both sides, I'm going to be able to subtract that off of both sides, leaving me with the measure of angle 2 is equal to the measure of angle 4. And since those measures are equal, and I could have put in another step where I switched it back to congruence, but if their measures are equal, we know they're congruent, and if they're congruent, then we know that those lines are parallel because of the converse of the corresponding angles postulate.